India's ambitious mission, Chandrayaan-3, is at the doorstep of the moon, hovering over its surface to soft land an object for the first time in the lunar South Pole, a tricky terrain full of craters and deep trenches. A successful touchdown of the lander Vikram, which is carrying the rover Pragyan, will be a significant leap for the India's space ambitions and also one for the world, as it will expand the knowledge of lunar water ice, which is potentially one of the moon's most valuable resources. The whole country is excited to watch the outcome in the next couple of hours. And in fact, there are reports of many institutions in India organizing prayers for the success. So what will the success of the landing mean for India and its scientific community? I'm Mohana Basu, assistant editor at ThePrint. Along with me, we have Sandhya Ramesh, the Print's science editor in Bangalore. Joining us from IIT Jodhpur, our guest speaker, Dr. Reetanjali Moharana, Associate Professor at the Department of Physics of IIT Jodhpur. Dr. Reetanjali's area of expertise lies in astroparticle physics, high-energy cosmic rays, gamma rays, and neutrinos. We also have Dr. Somak Raychaudhury, Vice Chancellor of Ashoka University, joining us. Dr. Raychaudhury has previously been at the Inter-University Center for Astronomy and Astrophysics in Pune. Thank you all for joining us today. I think we are all aware what a phenomenal engineering marvel this mission has been, and we are all hoping for its successful landing today. But what we want to discuss and address here today is what it would mean for the scientific community. So, I'll come to you, Dr. Raychaudhury, first. Why is it that the far side of the moon is so lucrative? Why are we all rushing or wanting to go there?
Well, there are many reasons. One of them, of course, is to demonstrate technologically that we can do this. It's very, very difficult. It's called the far side of the moon because it's unexplored, and it has, for some reasons we don't understand, a very difficult terrain. In the near side of the moon, we have lots of plain areas on which other missions have landed. And so we've stayed away from the far side because it is largely unknown. Even though maps have been gradually made since the 1960s of the far side of the moon, we know that there are very large craters, as you said, and mountains. So knowing that side of the moon is important. Just like, you're exploring the Earth. You've explored America and Europe, but you still have to explore Latin America and Africa, right? So the Southern Hemisphere is important.
Right, that's a wonderful analogy. But can you also throw light on why it is that it is difficult to make a landing in this particular part? What makes it? Yeah.
Right. So it's also connected to the interest, right? So you're asking about the scientific interest. It is it's very uneven. And so it's got very high areas of mountains and, of course, very big craters. I love the cat. And then, and because of these high mountains and craters, there are large parts. So that makes it difficult to land. Of course, to land, you need a pretty big space, which is plain, so that you can hover around as the lander would do. It goes about 1 kilometer above the surface and hovers around, finds a good place and lands. And if it doesn't land in a plain place, then it topples. And so that's very important. But as a result of this very uneven surface, there are very large areas where light doesn't reach. And these areas are sunlight doesn't reach. And so even in the lunar day. And so these areas can go down to as low temperatures as 200 degrees below zero. So these are places in which one feels there are mysteries, particularly water. Because from one of the things that we've learned from Chandrayaan-2 is that unequivocal evidence of water. We've got the water absorption line. We know it's there, but we don't know where it is. And one of the greatest candidates is the far side, where there are these large unexplored dark areas where we might have water. So water is one of the major reasons. And then the other reasons are, we want to understand the surface of the moon as much as we want, because the moon and the Earth are sisters. Actually twins. They form together from the same material at the same time.
Right.
And the distribution of stuff around the Earth and the Moon on the surface and below is very different. And so you can find things on the Moon on the surface that are not there on the surface of the Earth. And such things we've learned from the Northern Hemisphere. So from the Southern Hemisphere, first of all, we also need to understand why the Southern Hemisphere on the far side is so different from the near side. So we want to learn that. We want to know what we can learn about the Earth from the Moon. And then to study the distribution of various things on the Moon. So there are many, many things that we can learn from the far side.
Right. In a way, these areas are like time capsules, which capture some of very ancient history of our universe. Coming to you, Dr. Moharana, you of course are an astrophysicist who works with these high particle physics, as we call it. So what is it that you are looking forward to most once this landing becomes successful? If this landing hopefully becomes successful, what is it that physicists like you would be looking forward to?
Yes. Thank you for this opportunity. So basically my work area is cosmic rays and its messengers. How do we understand cosmic rays? So as you know, solar cosmic rays could not penetrate to Earth because of the magnetic field, the orientation of the magnetic field, and it gets oriented towards the poles, whereas Moon does not have it. Now, if it does not have a magnetic field, these cosmic rays are getting into the surface and then to the crest and then to the mantle of the surface. So the satellites, the payloads, which will be studying the crest, as sir mentioned, that there would be different kind of payloads measuring different structures of the Moon. The ones that would study crest or mantle can give us information what was embedded in these areas while the early universe was created. When I meant early universe, when the solar system was created, when this Moon was created and all, and how it was created. So basically, it will give us information how the planetary structure was formed from the solar system. So my area, what would be relevant for people like me would be to understand this data and try to interpret about the initial stages where the planetary system started. And for that, there are definitely lander payloads, which are like 4 in nature, which will be studying the plasma and then the seismic behavior of the mantle and the crest, and then the atmosphere and the surface structure, the surface content. So these are some of the parts that are relevant to all the physicists. I would say that starting from astrophysics, geophysicists, anybody who are doing seismology also, it is going to be a very interesting.
Right. We will talk about a little bit more about the payloads that the lander and the whole mission is carrying, but we'll know about that from Sandhya. But I'll come back to you, Dr. Raychaudhury, once more, that, what does, as you are now a vice chancellor at Ashoka, you see you're interacting with students. What kind of inspiration or what kind of meaning does these kind of launches have for the students who are looking forward to studying or getting into these fields of sciences?
I was just down there where they are doing a live broadcast among the students, hundreds of them sitting there watching this. And this is just on campus. And the kind of electricity in the atmosphere is palpable. Go to the campus, in the marketplaces. I mean, this is near Sonipat, which is a small town, large industrial areas, small schools, kids roaming around, excitement. They're even taking this as a nationalistic event where they're waving flags around. I mean, I've mentioned this before. I mean, I've seen this kind of enthusiasm among kids, amongst the general public, cheering, never for science in India. Cricket teams, yes. Football wins, yes. Not for science. And that's what excites me. I mean, the fact that people are cheering scientists, cheering technology. This is certainly a wonderful, wonderful, wonderful opportunity for us to inspire the younger people and to do something that we can do something to on India to inspire them.
Right.
On Indian soil, that is another thing, right? I mean, when I was young, people landed on the moon, and I was very, very excited. But that was done by the Americans. We didn't do it. The fact that 50 years later we can do this in Indian soil sends out a message to the younger population that, in order for technological advancement to happen, in order to do good science, you do not have to go to another country. We can do it. You cannot put a price on this. This is absolutely amazing. And I think in general, I can see this in not just college students. It's out there on the streets. People are happy.
It's everywhere. There are even memes of how Indians are normally fighting when watching cricket matches or something. And then for Chandrayaan-3, everybody's sitting together.
Yes, absolutely. And, like Dr. Moharana mentioned, that it's not just, it's not just about the current excitement, but what the data will bring for the Indian scientists, all across the country. People will have access to this data, and that can lead to new avenues of research too. So Sandhya, let us just quickly go over some of the payloads, some of the experiments and instruments that this mission is carrying, and what their, aims are in terms of what is it that they are looking at. And, we have done a very detailed article, and you can find Sandhya's article on our website. But let us just quickly walk through, some of those major missions.
Sure. So I'll just list out the payloads and explain what they do. And I think probably Dr. Reetanjali can explain a bit more, because a lot of it is high energy physics. So we have a total of 7 payloads. I'm just looking at my notes here. Vikram, the lander, carries 4. One is the Ramba experiment, which will study the density and variations in plasma around the moon. And plasma is the most abundant form of matter in the universe, and the moon is surrounded by plasma, which interacts with the solar wind as well. So that is something that the Ramba payload will study. Then there's the CHASTE, which will study the temperature, or rather the thermal conductivity and properties of the moon. It'll have probes, and it'll also have sensors that'll dig into the lunar soil or regolith for about 10 centimeters of depth, and then it will study how heat transfer takes place. Then there is ILSA, which is the Lunar Seismic Activity Detector. Moonquakes are not unusual. We do have moonquakes. It has to do with the fact that the moon is cooling and shrinking, and it is also under the influence of Earth's gravity. So because of that, there is energy release in the form of cracks that appear on the crust. So ILSA will be measuring moonquakes, and it will detect minute displacements and also the velocity of these quakes. Then we have the NASA payload, which is a passive payload. It doesn't do anything. It's the Laser Retroreflector Array. And this will be used for laser ranging studies, which is ones where you basically point a laser or source of light at the array, and then you calculate the time it takes to come back to the source. And because of that, because both bodies are in motion, we'll be able to understand the dynamics of the Earth-Moon system better, and also make the numbers more accurate. Then we have Pragyan payloads. Pragyan has 2. One is the alpha particle X-ray spectrometer, which will bombard the surface with X-ray or alpha particles. And then, this will be done through curium. And then the surface particles will get excited, and then it will help detect a bunch of elements on the moon, including rock-forming elements, such as calcium, iron, silica, and so on. And then the other payload in the Pragyan rover itself is a breakdown spectroscope. It's called LIBS, and this payload will basically calculate how abundant those elements are. This will also use high-powered laser, and when the radiation is emitted from after firing it, it will analyze that radiation and then deduce the density of the element. The last one is in the propulsion module, which is currently in orbit around the moon. The propulsion module carried Chandrayaan from Earth orbit to lunar orbit. And then Vikram is now planning to descend. But the propulsion module is still orbiting. It has a fair bit of fuel left. And this carries one payload called SHAPE. And this will study Earth's atmosphere from the orbit of the moon. And essentially what it would do is it will gather biosignatures that indicate the presence of life. and then use that data to sort of identify habitable exoplanets. Those are the 7 payloads that we have in this mission. And of course, there's also the lander camera, from which there have already been images that ISRO has released of the moon's surface.
Right. So, we have some questions coming in from our viewers who have joined us live. So, it's actually, this question is in line with what I was going to ask you next, Dr. Moharana. The question is, why is the moon so important for us to be explored for resources, as we as a generation lack a tech for space travel? Now, what I also want to, my question was in terms of what do these payloads bring for the Indian, scientific community? What does it mean for our future? And what are the kind of data or the kind of insights that we are hoping to gain? And that's where we bring in, why exactly do we need all of these resources when at this moment we do not have the technical capacity to actually travel to the moon?
Yeah. So as Ms. Sandhya mentioned, there are few payloads which will be measuring different contents of the moon. This data is going to give us information how a planetary system started at 4.5 billion years. Then the last one, the shape, the spectropolarimetry of habitat. This I just want to mention few points about this and why this is so important. Is actually we are looking for habitats, right? We are looking for a different Earth than our Earth. So we need some ground where we can start our search. Our ground is our Earth own Earth. Now we can form an orbit or a satellite who will be orbiting around our Earth at a height or at a distance of moon, and would capturing our Earth's atmosphere, our Earth's cloud. So the spectroscopy gives us information about the atmosphere, and the polarization would give us information about the clouds. Clouds and this atmosphere are the main reasons of our habitat. So shape would be giving us information if it is looking at a distance of moon, how a Earth-like exoplanet would look like. And this information, this data, can be a simulated picture for us when we will be looking for exoplanets. Okay, that's why this data is very, very important and essential at this point when we are actually looking for exoplanets.
Right.
There has been different techniques to detect such a thing, but of course this is a real data. You can see this is a real simulation model that we can put first.
Right.
So
right. So it can act as a model for what to look for. Sandhya, yes. I would just briefly ask you to, address the later part of the question where the viewer actually talks about, not having the tech capacity to be able to do space travel. But we do have programs, not just with ISRO, but also with private space agencies that are now starting to realistically look at space travel for humans. Can you comment on that?
Yeah, so I disagree that we don't have tech to go to the moon right now. It is not cost effective. That's what it is. We do have tech to go to the moon. In terms of humanity in general, NASA is picking up its Artemis missions again. And by 2026, the plan is that the first woman and the second man, first woman and a man will walk at the lunar South Pole. So as a species, we do have tech to go to the moon. And when reusable rockets, of course, become the norm, this will become much more cost effective and cheap. In terms of resources, the reason why we go to the moon primarily, I think instead of thinking about helium-3 and all of those, the prime focus is actually water ice. Water ice is what everybody is looking for in the lunar South Pole region in the southern hemisphere, and like Dr. Somak mentioned, in these permanently shadowed regions. And that is what all of these present missions, the upcoming missions as well, are going to explore over there. So once the role of water, the amount of water is quantified, we can sort of understand the role that water could play there. In the far future, the ideal future, The role of water would be both for sustenance to keep up human activities in the bases on the moon, as well as use it for fuel, because currently rocket fuel is made up of like hydrogen and oxygen, which we can get from water. And of course, you can also get oxygen. So water is the prime oil of space that everybody is going to the moon for. And then, in the farther future from that, it is, of course, believed that sending rockets from lunar orbit to low Earth orbit will be much cheaper from Earth orbit to low Earth, from Earth's surface to low Earth orbit, because of the lack of gravity, lack of heavy gravity. So we do have tech, and I think it is improving. And there are many, many countries now that are going to start going to the moon, because we understand the moon a lot more as well, as compared to what we did back in the 60s and 70s during the Cold War and the Apollo era.
Right. And it's also important to sort of establish our presence, demonstrate our tech, because, everything, space exploration is clearly very incremental. Every country is making their own set of progress. And why should we as a country be left behind in that? So another question we have is, why is the mission only for 14 days? So I think the straight answer to this is both the lander and the rover are solar powered. And since they will be only at the dark side of the moon, they will only have so much energy to run, basically 14 days. Am I correct?
Well, it's one moon day is 14 Earth days, and they run on solar panels. So when the sun sets on the moon, it will be 14 days of darkness and extreme cold. So the instruments and payloads will not be able to power themselves. Pragyan will not be able to power itself to move. Some experts believe that Vikram, because it's robust in design, might have a chance to survive the lunar night and then work again after 14 days. But we can't say anything about it right now. For now, we can just assume that the designated lifetime of both the lander and rover is 14 days from landing.
Right. Dr. Moharana, just to follow up to this question, to a layman, obviously 14 days sounds like a very short span of time. So, can you give us some, example or some idea of what this means, what these 14 days would mean for the scientific community?
So as Ms. Sandhya mentioned, it is a one-day moon.
Mm-hmm.
So as you know that it orbits about Earth for 27 days, and it's like it's completing one day. So that, of course, you need, when India is trying to launch something or it is making a payload, it will always be trying to make it as cheaper as possible. And because these are technologies which require so much money, the amount of gram you increase, the cost would increase like anything.
Right.
So 14 days is basically you want all the power that should be as natural to the instrument as possible, not to be provided all by sending it along with it.
Right. So in fact, that brings me to, Chandrayaan-1. Remember that the Chandrayaan-1 actually dropped an impact probe, basically dropped an object, which led to a little burst of moon dust, which also gave us enough data to say that there is the water on moon. So coming to more, we have a lot of questions coming in, so I'm going to try and take as many as possible. Sandhya, I think you can address this. Who are the other countries that have achieved soft landing on moon so far?
Just three. US, because of the Apollo programs. Russia, the former Soviet Union, because of the Luna programs. Luna was, in fact, the 25th mission of the Luna program. And China, which landed the Chang'e landers. In fact, China was the first country to land a probe on the far side of the moon.
Right. So that would make India the fourth country to make a successful soft landing. And we all have our fingers crossed for that. Another question that we have is, why did the Russian mission fail? So do you want to take that up? Sandhya?
Yeah, sure. They did release a statement saying that when they gave it a command, I believe for a burn to enter into a pre-landing orbit just before landing, it exceeded its parameters and it drifted away from the course that it was supposed to maintain and it crashed. That's the explanation that they've given, and they've described it as their as their craft ceased to exist, which is really unfortunate. It would have been very exciting to have two landers there.
Right. And in fact, like, we often describe this as a race, but the fact is that a lot of the space programs and the data that we get from them are open access, and researchers from across countries actually collaborate to, analyze these data sets. In fact, Chandrayaan-1's this water discovery was a collaboration with NASA as well. They were also looking at the data. So, this is, so it's not really, it's something that helps the entire humanity, and although we can take pride to if it's our own data. So all right, so I think this question we have already addressed. What does this mission mean for India's future space exploration? Where we talked about how the data of what the resources on the moon are can help us plan and prepare for what comes next in space exploration.
I want to add one bit to that, is that when missions like these become successful, it gives impetus for more funding and for more missions like this. So the success is crucial, and its impact will be larger on the space program of India itself.
Right.
Yeah, I also want to add one thing. There is an article by NASA in August 2020 that they also want to explore the South Pole of Moon. Of course, because of the reasons that Professor Somak mentioned. But again, they also want to understand the volatile materials that is there on the southern part of the moon, where there is no sunlight. The temperature goes like less than 200 or 400 Fahrenheit degrees. So how the volatiles, because volatile elements are the elements of habitat, like carbon, oxygen, nitrogen, which is in our atmosphere. So these volatile elements, how much is preserved in the moon? Because let me explain what is a volatile material or element. It is an element which will be in a solid form, and it will be vaporized within a moderate temperature. So even in the sunlight, it will vaporize. So the northern part of the moon may not have that volatile element. So one should look for the darker side of the moon. And NASA would be looking forward to see such kind of element on the southern pole. And of course, that they would also be planning to land there on the southern part, which is also their plan for a longer time.
Right. So, yeah. Sandhya, I have several questions asking basically the same thing. That is, what are the modifications that have been made to the lander this time? Why is, in fact, we are seeing ISRO a lot more confident than last time. So what are the modifications that is eliciting this kind of confidence?
Yeah, the vibe is definitely more positive, because ISRO has said that they have taken a failure-based approach. So what they've done is they have built redundancies around what led to the failure last time. So there was for example, central thruster that had malfunctioned in the last Vikram lander. So they removed it this time. They have strengthened the legs of the lander. They have also equipped it with more fuel and more solar panels for power. And they've also increased the landing area. So I believe it's a 4 kilometer by 2 kilometer landing area. So there is just a little bit more flexibility when landing this time. And also the structure is, in terms of engineering, more sturdy. So ISRO is definitely hopeful that this will be a success. From everything that they've communicated, that's what it seems like.
Right. Dr. Moharana, so far, in your research, what are the kind of data set sources that you, usually look at? Like, I just want to get an idea of, what the kind of difference our own data sets would make. So far, what are the sources that you usually look at?
So basically, as I mentioned earlier, I'm a high energy astrophysicist. I work on gamma ray burst. Those are extra galactic sources.
Mm-hmm.
So these are, of course, when I talked about gamma ray burst, they are again are people trying to understand how gamma ray burst affects habitat. How a gamma ray burst, how far from our galaxy can affect the habitat on Earth. So understanding the existence of habitat and the environment habitat, because if there is a gamma ray burst, it will burst the habitat environment of our Earth. So how this affects, how still Earth has this kind of living being and so populated, lively planet. So for me, for a person like me, this data by shape would be a very important aspect, and also because, as I mentioned earlier, cosmic rays are basically talking about how cosmic rays is interacting with the plasmas. So the Rambha data would be relevant for me. But anyways, as I mentioned, the chemistry people, the biotic people, the seismic physicist, geophysicist, anybody can use this data. As you can see, this is so many number of payloads are being landed, will be landing. Hopefully they will be landing.
Right. So over the next couple of hours, we'll first, of course, look forward to a soft landing, and then we will have the rover rolling out. And but it does not really end at the 14 days. We do have people looking at data from such space missions for years to come. Finding insights and in fact, like some of the older space missions continue to, get a lot of interest from researchers. Fresh eyes looking at older data sets also bring a lot of science out, and I think that is something that we'll be looking forward to for years now. Again, there is. Some of the questions are also wanting to know what to look forward to next in terms of ISRO's other space missions. So Sandhya, again, coming to you, we do have something very exciting just planned just a few days after this.
Immediately after, I believe on the 26th, we have the Aditya mission that is launching to study the sun. It's not going to go to the sun. It is going to orbit. It's going to be in a halo orbit, which is an orbit around nothing at the L1 Lagrange point, which is one of the 5 points in the Earth-Sun system, and it moves along with the Earth. So from there, Aditya will be studying the sun. That is the most exciting immediate mission. And then, of course, we have Gaganyaan tests that are planned, and we have the next Chandrayaan-4, which is still in conceptual phase, which will be actually a collaborative mission with JAXA, the Japanese space agency, to go to the lunar South Pole. ISRO is expected to build the lander, and JAXA will build the rover as well as their rocket. Did I mention we have Gaganyaan, and then in the future, of course, we also have this Venus exploration mission, a mission to orbit Venus and study its atmosphere. All of this is still in the planning phase only. The immediate next one to look forward to is Aditya.
Right. And in fact, later this year, we do have several test missions planned for Gaganyaan. And, it is a very exciting time for the Indian space industry as well, because we are seeing a lot of developments from not just from ISRO, but from private space agencies. And at ThePrint, we have been tracking some of these private space agencies, space startups, to see what it is that they are up to. And I do urge you all to go and read these articles. Now, I think that we are all very excited now to see the live telecast that will happen from ISRO, because we are closing in on the scheduled landing time. And I'm going to let Dr. Moharana and and Sandhya to go and just join the live feed from ISRO. That will start at 5:30, and you can watch the live feed here on ThePrint's YouTube channel as well. We do ask you to also keep following me and Sandhya. We are going to keep bringing you updates from this mission. And the Print's handle is, of course, running a live blog, which you must follow to get all the latest updates of this mission. Thank you so much for joining us, and thank you for all this insightful conversation. We're all very excited, and I'm also praying for a successful landing this time, and let's hope that things go well. And we come back to you with a conversation on what next after the successful landing. Once again, this is Mohana Basu, Assistant Editor at ThePrint. Do follow us on all social media platforms for the latest news updates.
Thank you, Mohana. Thank you, Dr.
Thank you.
Reetanjali, and thanks everyone.